Hello everyone. Okay, so in this video we are looking at what is calculus, and we're going to be looking at differentiation, more specifically differentiation by first principles. So first of all, what is calculus? So differential calculus is mainly concerned with measuring the rate of change. So the rate of change of one quantity in respect to another. So example, speed is the rate at which the distance changes with respect to time. So the longer you travel at a certain speed, the bigger your distance or more distance you will travel. So a rate of change that we're very familiar with in the that we should be very familiar with is the slope. So remember here, slope is equal to y2 minus y1 over x2 minus x1. So it's the change in the y values with respect to x. That is what the slope basically means. So calculus is just the rate of change, right? How fast something changes. So in order to look at calculus, a tool we use in calculus is called the derivative, and the derivative is a very important tool that we use. So the derivative is, so differentiation is the process of finding the slope of the tangent to a curve at any particular point, or the rate of change, the instantaneous rate of change at any point on a curve. So let's look at these two examples here. So here is my normal curve. This is a quadratic, so this is x squared. So f of x equals x squared. I picked 2 points here. So when x equals minus 1.5, if I draw a tangent line here and get the slope of this line, I find that the slope is 3. So I use like rise over run or whatever. If I say go on x0 and find the tangent line here, I find that the slope is 0 because it makes a perfectly horizontal line. Now, if I plot these points out here, where my x is like my slope, if my x is my given x coordinate and my y coordinates are my slope at any given point, if I plot these out here, so when x is 1.5, my slope is 3. When x is 0, my slope is 0. If I connect them up, this, and I find the equation of this line, this equation here now is my derivative. This is actually equal to 2x. So the function f of x equals x squared and its derivative 2x. So I've essentially now found the first derivative of this function. Now, imagine doing that for higher order polynomials. You're finding tangent point at like any given point and then plotting all them slopes. You're going to be there for ages. So that is why we need to develop some rules first. And the first rule we're going to look at is differentiating by first principles. But in order to do this, let me go to GeoGebra. So we're in GeoGebra now. So I have a curve here. This black line here is my curve. I'm going to pick 2 random points on this curve. I'm going to pick point x. And then x here, that gives me an output of f of x. Then I pick another point, x plus h. Let's put everyone on the curve. I plot it here, x plus h, go up here, and my output is going to be f of x plus h. Now, if you just come back to me now for a second, we remember my slope formula. Slope is equal to y2 minus y1 all over x2 minus x1. So we had one of my y points be f of x plus h minus f of x all over x plus h minus x. So these are my x coordinates and my y coordinates. If you see here, x coordinates x, y coordinates f of x. X coordinates x plus h, my y coordinate is x plus h. So if I simplify that down, I get now f of x plus h minus f of x all over, these x's will cancel out, and I have h. Now, this should give me the slope between them 2 points. Now, h is the horizontal distance between these 2 points. Now, if you look at here, I make h smaller. I make h smaller and smaller, and I'm smushing these points together, I'm making h, the horizontal distance between them, like close, 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 so close, and it's going all the way to 0. Boom. I get the slope of, I get the equation, I get a tangent line. So what we say is when the limit of h goes to 0 here, the limit of h goes to 0, that is going to be my derivative at that point of x. So let's show you how we do it here. So to derive the derivative of y equals f of x by first principles is defined by the limit of h goes to 0 of f of x plus h minus f of x all over h. This represents the rate of change of the function f of x at a particular point x. This is not in our log table, so this is something you have to learn. So differentiate the following function from first principles. 3x plus 7. So I have limit of h goes to 0, f of x plus h minus f of x all over h. Let's evaluate this now. F of x plus h, wherever I have an x, I'm putting in x plus h. So 3 times x plus h plus 7 minus my function here, which is minus 3x minus 7 all over h. This will be equal to 3x plus 3h plus 7 minus 3x minus 7 all over h minus 3x, 3x minus 7 plus 7. I'm going to be left with here the limit of h goes to 0 of 3h over h. H goes into 3h 3 times. So the limit when h goes to 0 of 3. Oh, well, we don't have any h's, so my limit is just 3. That means the slope at any given point on this line is equal to 3. So that's good, right? So lines have a consistent rate of change, and that makes sense, right? If I have a line here, its slope is always gonna be the same, so it makes sense we have a consistent slope. But if I have like a curve here like this, right? I'll use my ruler as an example here as my little line, right? My slope is always gonna change, right? Now I'm going down, wee. Now I'm going back up, wee. My slope is always going to change here, right? But for a line, it's always going to be consistent. Right, so let's look at this example now. Find from first principles the slope of the tangent to the curve with the equation x squared minus 2x plus 5 at the point where x equals minus 1. So we want to find the rate of change at x equals minus 1. So we're deriving from first principles, so we need to remember the limit when h goes to 0 of f of x plus h minus f of x all over h. That's going to be equal to x plus h squared minus 2 times x plus h plus 5 minus x squared minus negative 2x, which is plus 2x, then minus 5 all over h. That's going to be x squared plus 2xh plus h squared minus 2x minus 2h plus 5 minus x squared plus 2x plus 5 all over h. That is going to be cancelling terms here. Minus x squared cancels out with x squared. 2x cancels out with minus 2x. And there's some minus 5 here. Boom, boom, boom. Minus 5 plus 5. That is going to be 2xh plus h squared minus 2h all over h. That'll be now the limit when h goes to 0 of h goes into here, here, and here. So I have 2x plus h minus 2. When the limit of h goes to 0, I get 2x, then h goes to 0, minus 2. So that is my derivative, dy dx, right? That is the notation for derivative, by the way. And I want to find the rate of change at x equals -1. So sub it in. That is going to give me -4. So when x equals -1, the rate of change of this function is -4. Let's just look at one exam question here. So this came from 2022. I think as a recording this video, the last time it came up was 2024. So it seems to be kind of coming up every 2 years. So differentiate f of x, 2x squared plus 4x with respect to x from first principles. So limit h goes to 0, f of x plus h minus f of x all over h is equal to 2 times x plus h squared plus 4 times x plus h minus 2x squared minus 4x all over h. That is going to be 2 times x squared plus 2xh plus h squared, multiplying this bracket out, plus 4x plus 4h minus 2x squared minus 4x all over h. That's going to be minus 4x, 4x minus 2x squared. Oops, and then multiply this side out. 2x squared plus 2xh plus h squared plus 4x plus 4h minus 2x squared minus 4x all over h. So sorry, the 2x squared is going to cancel the 2x squared here, minus 4x is going to cancel the 4x. So I'm going to be left with 2xh plus h squared plus 4h all over h. Divide h in, h goes into here 2x times, h goes in here h times, h goes into 4h 4 times. Now I'm left with now the limit, and h goes to 0, of 2x plus h plus 4, and when the limit goes to 0, I'm just left with 2x plus 4. That is my derivative. So I can find now the rate of change of this function at any given moment here, right? And I think that's it for today's video. There's no need for me to do every question here because it's all kind of very repetitive in nature. So I hope this video was some help to you guys, and I'll catch you guys later. Bye.